Hey, this is Jody with weldingtipsandtricks.com. Today we're going to be doing a little TIG, a little MIG, and a little stick. And we're going to be doing all that on the same part that I welded in last week's video, which is this little mounting kit that adapts a air hydraulic cylinder from Harbor Freight to several different models of tubing benders. It's available from Swag Off-Road, so to learn more about it you can just go to swagoffroad.com. But last week I cleaned one up really good, wiped it down with acetone, and TIG welded it all the way out just because I thought that would be fun. So this week I'm going to be a little bit more realistic, and I'm going to do some stick welding for those that only have stick welders, and I'm going to be kind of comparing these two welders, this Miller 150 Maxstar STL to an Everlast 140 amp machine. Very small TIG inverters. So again, the kits look something like this. They're all laser cut, and the pieces that need to be indicated or located in a precise area have little tabs on them. So it's pretty kind of a no-brainer way to putting something together. There's really hardly any way you can mess it up. Pieces just kind of pop into place where they go, and then with just a little bit of massaging here and there and a little bit of tapping with a hammer, get them lined up, tack weld them, and weld them out however you want to. They're pretty clean. They got like a cold rolled finish on it. It's A572 high strength steel, so they don't really require any cleaning if you're gonna MIG or stick them, and really even TIG weld them. And I'm gonna do some TIG welding right now with the lift arc machines here. Now a lift arc machine, you've got to touch the tungsten to get the arc started. So I don't have a high frequency start where you can jump an arc gap with a foot pedal and everything. That's nice, that's the way to go when you can, but you don't always have that luxury. These machines are ones that you have to touch off to get the arc going. That's not such a big deal. The bigger deal is coming out. And I guess I got a trick for you to show you how to help you come out of the arc or come out of the puddle without leaving a crater eye. But I'm just kind of warming up here on some 11 gauge cold rolled steel. And you notice the valve on the torch. The Everlast machine does not have a solenoid valve inside the machine, and so it requires a valve torch. But they do supply it with the kit. It's a 17 torch, and I've got a little stubby gas lens kit hooked up with it. That's why I've got the nice little short gas lens arrangement on there, and I really do like that for 17 style torches. I like to make them a little bit smaller by putting the stubby lens kit on there. So that welded pretty nice, and having it on the angle iron there, it's easy to come out. You just kind of pause once you pull the arc off the end. So we're going to go ahead and weld the bracket, part of the bracket together. I'm at about 120 amps. This is again using the Everlast 140, it's called the PowerArc 140st. ST's for stick TIG. And we're going to compare it today. We're going to weld one of these in a minute with the Maxstar 150stl. The STL stands for stick TIG lift arc. There are some differences in these machines, so I'm not comparing apples to apples here necessarily. Alright, you see I've got the copper there next to it, and what I did is I just pulled up onto the copper to let the puddle solidify and then whipped out, so that's the trick to avoid leaving the crater eye. Okay, the way this the Everlast is set up, the argon comes right from the flow meter into the torch dens here. And that's a pretty simple arrangement. The Miller is a little different. It's got this little adapter piece here that seats up in the dens connector. So it's a through dens type argon thing. There's a solenoid valve inside the machine that detects, when you make contact with the lift arc with the tungsten, then your argon comes on automatically. So that's kind of a nice feature. It's just one of those things that not completely necessary, but nice. And then once you pop that in there, you just got to put a couple of wrenches on the torch and the adapter piece, get them all nice and tight, and then get the rubber protector boot shoved up on there, and you're ready to rock and roll. Now the Miller is a pretty simple setup here also. It does have a capability of a foot pedal. It's got a remote plug there for a foot pedal, which is nice. And then basically you just select whether you're going to be using TIG, remote, TIG panel, or stick, and then set the amperage and go. So here's the same joint, same piece of copper next to it with the Miller welder. Again, I believe I'm set on about 120 amps for this joint. Could be just a little less. feeding the 3/32 wire in there just a little bit as the joint will take it. This could be done. Some people would do this in 2 passes. Put a real small one in there first, and then come back with another one. But it's really not necessary. And again, we're going to come up onto the copper, let that puddle solidify, and out. That's what we get. And if you were watching both of them closely, I don't think you saw a whole lot of difference, because I sure didn't. All right, we're going to swap over to stick now. So I've got to pull the TIG torch out, put the ground in its place, and then hook the stinger up to the electrode positive terminal. Swap it over to stick and set the amperage down to around 90 something. I'm going to be using 3/32 Lincoln Excalibur 7018s for this, so about 90 to 95 amps should do a pretty good job. The Lincoln Excalibur rods are really nice. You can see I'm holding a pretty tight arc, not a whole lot of BBs jumping out of there, so amperage is pretty close. Not a whole lot of undercut or ends just melting away. So 93 amps is working pretty good. Probably could stand just another 5 or so for this joint, but it's fine. Again, still, this is the Everlast machine still here. I'm not making any kind of oscillation intentionally anyway. I'm probably shaking a little bit, making a little oscillation, but just kind of pulling along nice and steady. And you see with the Excalibur rods make you look better than you are sometimes. They help me anyway. And here's the Miller, set about the same amperage, but it is definitely a little hotter. So I should have set it down probably, I guess probably about 85 amps might be comparable. Still pretty smooth. Now for welding around this round piece, the handle here, the piece of tubing, you notice I got my rod in there kind of crooked, kind of bent down. And the reason for that is, on something round like this, I really don't want to make a tie-in, because it's kind of hard to make a good tie-in on something that small without just it being really obvious. So with the rod being in there crooked like that, you see I just twist my wrist, and I can kind of keep a good angle all the way around and make a one run without stopping any. And also a file is good to have handy. These 7018s, no matter how good of rods they are, they're hard to restart, but if you have a file handy, you can knock that tip off there and they start a lot easier. Now this is the Miller going in the other direction. You can see I've got a few BBs here. I left the amperage the same, and it's a little hot, so it's not running quite as smooth. But so there's the two run all the way out, and some TIG welding on the other half, done with each machine, and the rest of it was stick welded out. They look pretty similar. Again, like I said, if I had dialed the Miller in, it probably would have done a little bit better, but it was welding just a little bit on the hot side, so I've got some BBs here and there. Now most people will MIG weld these things, so I decided to MIG a few joints here just to kind of show you that. I used about 18 volts, about 245 inches a minute, using 030 ER 70S6 wire. That was pretty close to a good setting for the outside corner joints anyway. Not bad for the whole thing. Again, I'm just using this little series of kind of cursive E's or U's or whatever. Could have been a little hotter, but did okay in the long run. Again, this is only 1/8 inch tubing for the handle here, so if I go too hot, I'm going to melt through. And the MIG welding went okay, a little bit of cleanup, a little bit of spatter, and that's it for today. Thanks for watching. Visit weldingtipsandtricks.com.